Hello, my name is Mark, and today I'm going to be going over 10 test day moves you need to know. This is the last minute game plan. This presentation is designed for those individuals waiting in their car outside the testing center to take the IBEW Aptitude test. Make sure to like the video. I want to let you know that I will be going fast in this presentation. It is not like my usual videos where I break things down slowly. It's going to be fast. No need to take notes. This is what I will be going over. It's going to be 10 test day moves as well as 2 bonus ones. The first one, identify the question type. Before solving, ask, what does the question want? If you see simplify, your first move is to combine like terms. If you see evaluate, your first move is to plug in values. If you see factor, rewrite into parentheses. If you see solve isolate, get the target variable by itself. If you see graph match, find slope and intercept. If you see cutoff, set the target variable equal to 0. If you see number series, look for the pattern. Bottom line is do not solve randomly. Identify the move first. Next slide, I have examples. 3x minus 2 squared minus 2x plus 4 squared. The question type here is to simplify. Expand, right? We would expand x minus 2 to x minus 2 times x minus 2, as well as this over here, x plus 4 in parentheses times x plus 4, or both of those in parentheses. After expanding, we would combine like terms. The next example, I have 2y minus 3w plus h. The question type is to evaluate. I would plug in the values. Y is equal 1, w equaling 2, and h is equal to 3 into this formula here, and then evaluate. Factor, I would find 2 binomials, right? So we have 12 here. What 2 terms multiplied together equals 12, and then combine equals 7. And then after that, I would get the 2 binomials, x plus whatever, and then x plus whatever. Solve isolate given this. So let's say I want to isolate C1. The first thing I'm going to do is clear the denominator down below. And in order to do that, I just need to multiply by C2 minus 3 to both sides, clearing the denominator. I'm not going to solve further. Next, I have graph match. The question type is graph match, and I have 6y equals 12x minus 42. Well, the first thing I'm going to want to do is to simplify and then rewrite as y is equal to mx plus b. I could simplify all this by dividing every term here by 6. Next, I have cutoff, right? P is equal to 16 minus 2q. When is p less than 0? And then the first thing I'm going to do, because the target variable is p, I'm going to set p to 0, making the equation 0 equals 16 minus 2q, where I would find q, which would be the cutoff. Next, I have number series. I'm given a series of numbers, and then I'm going to be looking for a pattern. Okay, next slide. Check the slope first. This is for graphing. Before matching a graph, ask, is the slope positive or negative? Right? If the slope is positive, the line should go up from left to right, right? From left to right, going up. Negative, go down from left to right, right? Down from to left to right. 0, be horizontal, right? It could be, let's say, y is equal to positive 9, and it'll be this right here. Okay, this is just a rough sketch. Undefined, it's vertical. Yeah, vertical, it's going to look something like this. Okay? Bottom line, the slope tells direction before anything else. Then I have examples here. So when you are looking for the slope given an equation, you're looking at m. In this case, m is equal to 2. Right? And this is a positive slope because there's no negative sign over here. It's positive. We're going to be looking for a line going up. Let's say we're given multiple graphs. I would rule out negative slopes, I would also rule out the horizontal lines or undefined, right? So that's what I'm trying to teach you guys here. I have another one right here. Y is equal to negative 2/3 x plus 4. Well, I know that this is a negative slope. It has a negative value or a negative before the value, right? Giving me a negative slope. Negative slope, look for a line going down. Okay, y is equal to negative 9. Well, that doesn't give me a slope at all. It's just going to give me a straight line. We're going to be looking for a horizontal line. If we're given x is equal to negative 9, we're going to be looking for a vertical line. Okay, I have some examples here. All these graphs right here, 1, 2, 3, and 4, are these right here, are these formulas. Okay, so I have y is equal to 2x minus 7. Well, that is a positive slope, right? 2x is positive, or 2 is positive. The second one was negative, right? It was negative 2/3 x. It's a negative slope. Right here is a horizontal line. Y is equal to negative 9, and this is undefined. X is equal to negative 9. Okay, recognize these when you are looking at the graphs. Okay, after you check the slope, you're going to be looking at the y-intercept, right? Where the graph crosses the y-intercept. Okay, if the equation is 2x minus 7, the intercept is 0, negative 7. Why? Because if we set 0 for x, we would get negative 7, right? 0 as in x, and then y would be negative 7. Same as if we put 0 for x again, we would get y is equaling to 4, giving me an intercept of 0, 4, an ordered pair of 0, 4. In this case, y is equal to 5x. There is no b, right? B is equal to the y-intercept. There is no b, but if we put a 0 here like this, that is our b. That is actually our b, but we would never do that, okay? Given this, we know that the y-intercept is at the origin, okay? Then we have this here, 4x minus 2y equals 14. This is not written in y equals mx plus b, but that's what I would do. I would rewrite this into y is equal to mx plus b, and if you simplify and rewrite to y equals mx plus b, you would get y is equal to 2x minus 7, right? 4x minus 2y equaling 14. Divide everything by 2. Divide everything by 2. I get 2x minus y equaling 7. And then I would minus 2x minus 2x. I get negative y is equal to 7 minus 2x. Distribute or just divide by negative 1 for each term. And then I would get y is equal to 2x minus 7. And I just prove that this is just this equation here. And then I mentioned that b is equal to the y-intercept, right? So if you're just looking at the equation, y is equal to 2x minus 7, we know that b is just negative 7. Our y-intercept is 0, negative 7. We would look for a graph crossing at negative 7. Over here, b is equal to 4. 0, 4 is our ordered pair, and we're going to be looking for a graph that crosses at 4. Over here, we get y is equal to 5x. I'm looking at b is equal to 0, or we're just looking at the origin. I know that I'm going to be looking for a graph that crosses the origin. Over here is just the same. These two are the same equations. I would isolate first, isolate my y, simplify, right? Because we could divide everything by 2. And then I would look for a graph crossing negative 7 because I would have gotten this equation after rearranging into y equals mx plus b. Okay? And then I have the same graphs as the last move. And then this time I just wrote the equations above. And then negative 7 is my y-intercept. And it's right here. Over here is plus 4 is my y-intercept. 5x, I have 0, 0 at the origin is my intercept. And over here is just the same graph, right? And then my y-intercept is negative 7. Okay, you know now how to identify a graph using the slope and the y-intercept, a linear graph. Okay. Number 4, use the coefficient. Before solving, ask, is the coefficient positive or negative? This is when dealing with problems like this. Consider the following formula. R is equal to 18 minus 4t. Which of the following statements is true for this formula? These are the problems I am talking about, the questions that I am talking about in this test day move. Okay? If the coefficient is positive, the variable will move in the same direction. If it is negative, it will move into opposite directions. Bottom line, positive equals same direction and negative equals opposite direction. Okay? Let me demonstrate here. So this is what I'm looking at, right? I am looking at this right here, the coefficient with the variable here, and the variable is k. I notice that the coefficient is -3. So I know whenever I choose any number and just plug it into k, if it'll be opposite, right? The sign will be opposite. The relationship will be opposite. Over here, I have a positive value or a positive coefficient, right, tagged along to this variable. And if it's positive, the relationship of Q and P will be in the same direction. Okay, if Q increases, then P increases. So I have a negative coefficient. So what's going to happen? Well, the relationship between T and R is they will move into opposite directions. If T increases, well, R is going to decrease, right? Let's do this in real time. R is equal to 18 minus 4. Let me say that T is equal to 1. Right? I get R is equal to 18 minus 4, and then R is equal to, what is that? 14, 14, right? Well, let me increase T, because if T increases, then R decreases, right? So let me increase the T now. So I go R is equal to 18 minus 4, and I'm just going to increase it by 2, okay? Increase it by 1. R is equal to 18 minus 8, and then R is equal to 10. What happened to R? Well, R decreased, okay? The opposite directions. The relationship is opposite, okay? Let's go ahead and look at an example. So I already did this. Look at the coefficient, right? Given R is equal to 18 minus 4t, let's look at the coefficient, -4. A negative coefficient means opposite directions. So if T increases, then R decreases, and vice versa. So in this case, we have the answer here. If T increases, then R decreases. Right? Decreases. I misspelled that. This matches B. Okay? Next, we have the cutoff. Before choosing an answer, ask which variable is the question asking about. So if the question asks, when is P positive, right? The target variable is P. So we set P to 0. When is P negative? Well, again, the target variable is P. So I have to set P is equal to 0. This says, when is X greater than 0? Well, the target variable is X. So I have to set X equaling to 0. When is S less than 0? Well, the target variable again is S. Okay, we have to set S to 0. The bottom line here is the target variable gets set to 0. Okay. So here are some examples. P is equal to 16 minus 2Q. When is P negative? What is the target variable? It's not Q, it's P, because it's asking when is P negative. We're going to set P to 0. We find the cutoff. After simplifying, we get Q is equaling to 8. And then in cutoff problems, what we want to do is find out what happens above and below the cutoff. So I'm going to set Q is equal to 9 and then solve for P. What happens to P? And then I'm going to put Q equaling to 7. And then again, see what happens after I simplify and then what happens to P. Okay? That's what we're doing with the cutoff. P is equal to 3r minus 12. When is P positive? The target variable is P. I set P to 0, and then after simplifying or after plugging in P to 0, I get R equaling 4, equaling my cutoff. X is equal to 4y minus 27. When is X greater than 0? Okay, my target variable is X. I set X to 0. I find the cutoff. Y is equal to 6.75. Okay, last one, S is equal to negative 6t plus 24. When is S less than 0? Okay, when it says something like this, X is greater than 0 and values less than, S less than 0, this is positive values and this is negative values, okay? The target variable, again, is S, okay? Set S to 0, you get the cutoff, T is equaling to 4. This is question 19 from practice test number 3. And it says here, which of the following statements is true for this formula? I am going to test the first statement here. Question is, when is P negative, right? It says here, if P is less than 0, so it's saying P and then less than 0, okay? P negative, the target variable is P, so I set the target variable equal to 0, okay, P right here, 0, equals 16 minus 2Q. We solve for the cutoff, so I add 2Q to both sides, giving me 2Q equals 16, divide by 2, I get Q is equal to 8. I'm going to test above the cutoff, so I get Q is equal to 9, okay? And then I just plug that in to the original equation here. P is equal to 16 minus 2, and then Q is 9 now, okay? I get P is equal to 16 minus 18, equaling negative 2. Well, I can tell you from here that when you choose a value greater than 8, which is 9, you will get negative values. Okay, if P is negative, and then I meant to put then, if P is negative, then Q is greater than 8, okay? Or vice versa is when choosing values greater than 8, P is negative, making A the correct answer choice. All right. Next, test day move. Number 6, plug in the numbers. Before choosing an answer, ask, did the statement give me values to test? Okay, this one we're just plugging in numbers. If the answer choice says if X equals 1, then the first move is to plug in X equaling 1. If X increases from 1 to 4, well, we're going to plug in X for 1 and X to 4 and observe what happens. Okay, if R is equaling to 5, then, well, the first thing that we're going to do is plug in R equaling 5 and then see what happens. If Y increases from negative 1 to 5, we're going to solve both values. Just like we did for X, we're going to see what happens when we make Y negative 1 and then Y 5. Okay? Bottom line is, do not guess the relationship when given values. Test the values. Okay? Next slide. Okay. I have Y is equal to negative 2X plus 7. If X goes from 1 to 4, I would test X is equal to 1 and X is equal to 4. Then I would compare the Y values. Observe what happened. N equals 30 minus 5R. If R is equal to 5, then N is equal to 0. First, we're going to test R is equal to 5. See if N does equal 0. If not, the statement is false. If it's true, if N does equal 0, then that's probably the correct answer, depending on what the question is asking. Y is equal to negative 2X plus 7. If Y goes from negative 1 to 5, well, we're going to test Y is equal to negative 1 and Y is equaling to 5. We're going to solve for X, then compare. Okay, just like we did on the first example here. So, given this question, given the equation Y is equal to negative 2X plus 7, which statement is true for this formula? Well, let's just check statement A. If X increases from 1 to 4, then Y increases. Well, let's test for X is equal to 1, and let's plug that in. Y is equal to negative 2X, or 2, and then 1 plus 7, this equals 5. And let's see what happens when we test x is equal to 4, y is equal to negative 2, 4 plus 7, that equals negative 1. What happened to y? Well, it decreased when we increased x. What happened to y when x increased? Y decreased. This statement A, or answer choice A, is false. So we would repeat and test the other statements here. Okay, just plugging in the values. This one's super simple, guys. This is again from practice test number 3, question number 16. Okay, next move I have here, number 7, use the answer choices. Before choosing an answer, ask, can I test the answer choices? If the question asks factor, the first move, I could FOIL the answer choices. If the question asks solve for a value, I could plug choices back in, right? I could plug in the answer choices back into the question. If the question asks match a graph, I could eliminate wrong slopes and intercepts. If the question asks true, false statements, I could test the statement. Bottom line here, sometimes checking the answer choices is faster than solving from scratch. Example, 6x squared plus 11x plus 3. The target variable, factor. I think this is wrong, but factor, right? The question is asking me to factor. The first move is FOIL the answer choices. I get here x minus 3 over 6 equals 5 over 8. Instead of solving, right, it's asking us to solve, right? And we could cross multiply. I could cross multiply 8 and then multiply this by x minus 3 and then 6 times 5, cross multiply, right? Well, I could just plug in the answer choices. If they give me the answer choices, I could do 6 minus 3 over 6. I could just plug it in, given the answer choices. Y is equal to negative 2/3 x plus 4. Graph match. Eliminate the wrong graphs, given that I know that this has a negative slope as well as a y-intercept of 4. Statement testing, I could plug in r is equal to 5, okay, from the answer choices. Here's an example. So 6x squared plus 11x plus 3. Instead of factoring from scratch, I could test each answer choice here, right? I could FOIL 3x plus 2, or not plus, 3x times 2x, 3x times 3, and then 1 times 2x, and 1 times 3, and just FOIL each one. And then I find out that D matches, okay? After foiling each answer choices. It's actually faster to do this rather than to solve from scratch. And I've done that before on one of my videos. I have here number 8, watch the algebra traps. Before moving on, ask, did I handle the signs, fractions, and exponents correctly? I've had many people tell me that the most common mistake that they make are stupid mistakes, silly mistakes, right? They tell me, oh, I forgot to carry down the negative. Well, I'm here to tell you not to do that, okay? Watch for the traps. Common trap, square binomials. What to remember, do not forget the middle term. Negative signs, distribute the negative carefully. Fractions, use common denominators. Not true questions, look for the false statement. I know we're so used to finding the true statement that when we see not true, it messes with our brains. Exponents, subtract exponents when dividing. Bottom line here is small algebra mistakes can change the whole answer. Next slide, I have x plus 4 squared. I'm missing the middle term. Okay, the trap is missing the middle term. We would rewrite as x plus 4 times x plus 4, right? X plus 4 and then x plus 4 both in parentheses. All right, instead of thinking that, oh, this equals x squared plus 16. It does not, okay? It's x squared plus 4x plus 4x plus 16, giving me x squared plus 8x plus 16. I think it's that. But just remember to get the middle term down when squaring a binomial, okay? And then here, sign mistake, negative 3 distributed here in parentheses, 2x minus 5. Remember to distribute -3 to both terms, to the 2x and the -5. And a negative times a negative equals a positive. Okay, don't forget that. These are silly mistakes. These sound silly for me to talk about, but people do make these mistakes. I have here fractions, 1/2, 9/8, and 7/4. They have different denominators. The first thing that I would do is convert these, right? This 2 and this 4, I would make them 8. So they all are 8. Okay, or I would divide this by 4, then divide this by 2, but then dividing this by 4 gives me an ugly number at the top. So I wouldn't do that. I would just multiply this by 4, right, on both sides, both the top and the bottom, and multiply this by 2, the top and the bottom, okay? Which is not true, okay? The trap is reading too fast. The first move here is just to find the false statement. Again, we're so fixated on finding the true statement that when we're given which is not true, it messes with our brain to find a false statement. Okay, over here, I have x minus 4 squared, right? Do not write x squared plus 16. One would think that they would do that, right? To distribute this exponent, and then that's it. Well, rewrite it, and then you would FOIL, and then get this, and then this right here. People forget this right here. Believe it or not, they forget that. Okay, combine like terms, and you get this, x squared minus 8x plus 16. Okay, little mistakes like these ones right here, they cost easy points, and you do not want to miss these points, guys. Let's go ahead to the next test day move, and that is to look for the number pattern before choosing an answer. And before I go over this one, this is for the number series. Okay, before choosing an answer, ask what is changing from term to term. If we're given whole numbers, check addition, subtraction, multiplication, or division. Okay, if you see every other number changes differently, split the pattern into odd and even positions. I go over this on the example. If we're given fractions, convert to common denominators. Decimals, find the difference between terms. That's the only thing you could really do. Bottom line, do not force one pattern. Test the simple moves first. Okay. Here's an alternating pattern: 4, 27, 8, 22, 16, 17, 32. 4 to 27, nothing, something happens, but then you go 27 to 8, then it just messes up whatever thought process you had here. Well, if we split it, we get 4, 8, 16, and 32. What's happening? It's doubling. When we get 27, 22, 17, what's happening? We're minusing by 5 or subtracting by 5. Okay, split the odd and even positions. Here's a fraction pattern: 1/2, 9/8, 7/4, 19/8. Well, I want to convert all of my denominators, right, to eighths. So I get 4/8 and then 14th eighths. 14th eighths. Yeah. And then I would find the pattern. Here, decimal pattern, check repeated change. And then I would go like from here to here, and then find out from here to here, I get plus 0.75. From here to here, I get plus, again, 0.75. And then along the way, you just find out it's 0.75, and just do it again to the last term, and there you will get your answer. Okay? Here is the example. What is the next number in the following series of numbers? And guys, if you're watching this, this is from practice test 3, question number 7. And I already did this one. 4, 8, 16, 32. This is an alternating pattern. What's happening here is it's doubling here. And what's happening here is it's minusing 5. Minus 5 from 17, you get answer choice 12, or answer choice 12. B as your answer choice, and it is 12. Okay? Last tip is protect your time. Before getting stuck, ask, do I know my first move? If you see, the question type, right? Start solving it, okay? If you know the first move, try it. If you are stuck after 20 to 30 seconds, mark it and move on, because you're going to be given 1 minute and 30 seconds and some change to figure out each answer choice. But the thing is, there are some questions that take up more than 1 minute and 30 seconds. And then there's some that only take a few seconds to solve. Okay, so you want to allocate your time doing all the easy questions before moving on to the ones that you're stuck on. Okay, if you are stuck, if you are doing too much work on a question, look for a faster move, or stop doing that question, move on, save it for later. Okay, bottom line here is do not let one problem steal time from easier points. Okay, it's not about getting a 9 out of 9 on the aptitude test. Okay, it's about passing the aptitude test. Okay, when you're at the interview stage, the people interviewing you aren't going to be like, this dude right here, 9 out of 9 on the aptitude test. He's definitely going to be an electrician. No, all you need to do is pass it. And then you could focus all your time on the interview questions. Okay, protect your time. If you see a hard quadratic, this could take a while. Save it for later if needed. Long formula rearranging, easy to get lost, clear the denominator first. Hard number series, this can waste time. Try simple patterns first, then move. Graph matching, these are actually faster than they look. Check the slope and the intercept, the y-intercepts, as well as the x-intercept. And then pick the best answer choice. Test day game plan, identify the question type, make the first move, eliminate bad answers. If you're stuck, mark it, and then come back with fresh eyes. Okay, easy points. Okay, easy points first, right? Like I mentioned before, the time meters are second. Every question is worth the same, but not every question takes the same amount of time. I'm not the first one to say that. Okay, that's why I put it in quotation marks. So keep that in mind when you are taking the test. Okay. Bonus test day move, reading comprehension. Remember this, read first, track the paragraphs, then go back for the evidence. A lot of people I noticed, or just some people have said to read the questions first and then go read the passage. I don't believe that. I think you are doing double work when you're doing that. Read the passage first, okay? When you read the passage first, the purpose is to understand the big picture. And then make mental paragraph notes while you are reading, okay? When you do that, you know where to return after you read the questions. You read the questions carefully, you've created these mental notes, you know what the question wants, okay? Go back to the passage. The purpose is to find evidence, okay? Because really the point of these questions is to just find enough evidence to support the best answer choice, okay? That's it. Pick the supported answer, avoid trap choices, because sometimes there will be two answer choices that sound very similar, but one thing will be off. Okay, and I do go over in depth on how to answer these type of questions. But again, that probably isn't for you because you are in your car right now waiting to take the test. This is just an overview, okay? A quick overview of what to go through and what to expect on the test. The bottom line here is the correct answer must be supported by the passage, okay? And again, read the passage first and then go back and then answer the questions or read the questions. This one here, I was iffy on putting this one, okay? Because again, there's only a select few people that see parabolas. And when you do see parabolas, I know you don't have to go super in depth, but here, I got this slide just for you if you do happen to see a parabola. If you see, ask yourself, do I see x squared? If yes, think parabola, okay? When you have a positive a, it opens up. If you have a negative, it opens down, okay? X is equal to negative b over 2a. This formula is needed to find the vertex, given the formula in standard form. Standard form is here. Y is equal to ax squared plus bx plus c. This is standard form. Okay, you would plug the x back in after solving, and then you would find the y, and after that you have found the vertex of your parabola. The vertex is just the highest point in your graph or just the lowest point in your graph. And this is a negative and this is a positive parabola. Okay. C in y is equal to ax squared plus bx plus c is your y-intercept. Okay, y is equal to a, and this is the vertex form. I don't want to read that out loud, but then the vertex is just h and k. Okay, and then remember when you were finding the vertex in vertex form, this negative h or whatever value is there is the opposite. So let's say it's 4, right? It goes x minus 4. Well, it's going to be
positive
4 as your h. Okay, it's always the opposite of what you see. Okay, set x to 0, you find the y-intercept in any form. Set y, oh, I'm sorry, did I say y? Set x to 0, find the y-intercept in any form. Set y to 0, find the x-intercepts using the quadratic formula. Okay, bottom line, you check the direction, okay, positive or negative using A, you get the vertex using this right here, this section, and then you find the intercepts using this right here. Okay, very quick overview on parabolas. And that, folks, concludes the 10 test day moves you need to know for the IBEW aptitude test. This was a quick one, all right, and that's it. Markyfbaby out. I will see you on the next video. Goodbye. Good luck. And guys, I just want to say a quick prayer, and it's just a Bible verse that I put on all of my videos. With God, all things are possible. In Jesus' name, amen.